We're going to do trig integrals. In this particular video, we'll deal with tangent secant, and we'll have both tangent and secant being odd powers. As an example, let's look at tangent cubed x secant cubed x dx. With tangent secant, we have to recall that the only two antiderivatives we're going to be using are that the integral of secant squared x dx is tangent, or we use the integral of secant x tangent x, and that's secant x, and of course both of these plus c. Also, we're going to be using just two Pythagorean, aspects of the Pythagorean identity. One is we'll be able to replace tangent squared with secant squared minus 1, and we'll know, of course, that secant squared can be replaced with 1 plus tangent squared. So we'll be using these bits of information to help us solve these integrals. With this one, what we're going to do is we're going to pull out the one secant, one tangent, which is going to leave squares, and therefore we'll be able to use the Pythagorean identities. So I'll rewrite this as tangent squared x secant squared x, because I pulled out one secant x tangent x with the dx. This becomes my du, so I know that du is secant x tangent x dx, and therefore we know that it came from secant x. That means I will change the tangent squared here. Everything has to be made secant. Tangent squared will be replaced with secant squared x minus 1. This can now be written, having replaced tangent squared with secant squared minus 1. It's going to be secant squared x minus 1. We have our secant x tangent x dx. And we're now ready to replace everything with the u and the du. U being secant, this becomes u squared minus 1, and this is du. I forgot the secant squared, so let me put that in. I now have, with the secant squared, that's u squared. So now this is the integral of distributing the u squared through u to the fourth minus u squared du. And the antiderivative we can work is u to the fifth over 5 minus u to the third over 3 plus a constant. But we have to go back to the original function in x, which is secant. So this is secant to the fifth power of x over 5 minus secant cubed over 3 plus a constant. We're now going to do another case. Let's do, as our second case, tangent and secant both are even. The example I'm going to do is I'm going to look at tangent to the fourth x secant to the fourth x dx. And we have to think about how would we work this given our original antiderivatives and the Pythagorean identities. The minute we have secant to an even power, it's very nice because we can pull out secant squared, and du would then be secant squared x dx. Working this can be written as tangent to the fourth x secant squared x, and then we've got our secant squared x dx. Secant squared x dx is du, which means it came from u, which was tangent x. So we are going to have to transform secant squared into tangent squared, some Pythagorean identity involving that. We know that secant squared is 1 plus tangent squared. So in this case, we're going to distribute this through. So this becomes the integral of tangent to the 4th x plus tangent to the 6th x. And then we've got that secant squared x dx. But changing everything to u, this is u to the 4th plus u to the 6th du. And that antiderivative is straightforward. We get that it is u to the 5th over 5 plus u to the 7th over 7 plus a constant. But we always have to go back to the function of x. Because u is tangent x, we just write it as tangent x to the 5th power over 5 plus tangent x to the 7th power over 7 plus a constant. I'll go to the next page and we'll do what's the hardest case. Our last case is where you have tangent and secant. And the hardest case is when secant is odd, but tangent is even. Let's look at the integral tangent squared x secant cubed x dx. I can't take out a secant squared as du because I'm only left with a single secant and I need squares or multiples of 2. And I can't take out one tangent for the same reason. So in this problem, we're going to replace tangent squared with secant squared minus 1. This now becomes distributing the secant cube through. It's secant to the 5th x minus secant cubed x dx. This problem involves integration by parts or the use of the reduction formula. So you would either have to create your reduction formula for each one separately or use one that we already have. So I'll write etc. because you're going to have to use the reduction formula.